We're going to construct the midpoint of a line segment. So what we're trying to do is find where the middle is exactly. To cut a segment in half is to bisect a segment. So when we locate the midpoint, we're finding a place where we can bisect the segment. We use our compass by first measuring the distance between A and B, and we can create two circles with our compass, same size, around both points A and B. Now sometimes these circles wind up being a little too big for us, so what we can do instead is we can adjust the compass to make it a little bit shorter, but not too short. We want it to be at least more than halfway on that line segment. Now creating two circles around points A and B respectively, the same circle, we find that these two circles intersect each other. At these 2 points, if we take our straight edge now and line it up, we can locate the exact middle of the segment AB. Using our straight edge to mark where the middle is, we then can put a point there labeled capital M for midpoint. That is the middle of the line segment, cutting it into two congruent pieces. We can say that segment AM is congruent to segment MB. Now, something else what we might take note here is that if we were to connect those two intersection points of the circles with a straight line using our straight edge, we notice that line goes through the midpoint, and that would be the perpendicular bisector of the line segment. So the line itself is the bisector, and it is perpendicular to the original segment. So it's called the perpendicular bisector. It forms a right angle with the segment. You get two constructions for one method in this particular one, the midpoint and the perpendicular bisector construction. These take some a little bit of practice, but this one's a relatively easy one to master. Now, if we want to bisect an angle, that's going to take a few more steps. So let's create an angle for us to bisect, or cut into half. So we're going to start by creating an angle with vertex point P, and I'm going to take my compass and construct a circle around vertex P. Where it intersects the angle, I'm going to label those points A and B, and I'm going to create two more circles of the exact same type centered around each of those points. We notice that the circles intersect each other here at point C, and if I were to line up my straight edge, which I'm doing here now, with the vertex and that intersection point C, drawing the straight line creates the angle bisector. The line segment PC, or the ray BC, or the segment PC, is the angle bisector in this particular case. It cuts the angle originally into two equal halves. We say angle BPC is congruent to angle APC. Again, noting that the vertex letter is in the middle, and we have two equal half angles. Angle bisector construction. So we'll do this a few more times just to get the gist of it. Here I'm going to again create an angle to cut in half. Call this angle Q. I put a circle around the vertex and two more circles around the intersection. And connecting the points that they create, we get a line segment. Here QR I'm going to call it. And that'll give us the angle bisector. QR is the angle bisector. All right, let's just see that one more time, maybe with not so many circles and just using a little bit of the arcs here. So pieces of a circle are called arcs, or parts of the circle. So we only need the points where they intersect. This is a sort of more cleaner construction, and that gives us the angle bisector as well. So let's just take a look at some angle bisector constructions by hand.